functions. So we have management, we have authentication, we have access points that somehow communicate across wired links, and obviously in the end of the day, all this serves for wireless nodes, stations, clients. As for the, say, architecture, in the SWAN generation, there was no managed access points in the sense they were dumb and were configured centrally, but they were still autonomous, but could be configured by means of a central entity. Think like Cisco works configuring devices, and this is much or less the same what happened in the SWAN world. There were two possible management say devices, the WLSE, the one we have here, or there was a module for the CAT 65K. In the overall picture, Cisco introduced a term called wireless domain services, which can be thought of, say, the whole of the communication services and services provided by the architecture. And the communication between entities, mainly between access points, were implemented with the help of a proprietary protocol called WLCCP. This is where I switch over to Ollie, who did the main research work as for WLCCP.
Okay, so you can hear me? Hello again. WLCCP is the protocol supporting all this wireless domain service structure. The structure is always involves this that there's somehow a controller which does some, say, the management, the centralized management stuff, which is also responsible for some kind of authentication functions and stuff like that. And I mean, the protocol this is really highly proprietary. There's two patent application which describes part of the protocol. Really, it's only parts of the protocol. You can say, okay, all the unencrypted stuff, all the data which is transferred unencrypted within the protocol is described in these patent applications. The rest, which is somehow transported in an encrypted way, that is completely undocumented. So it's kind of it's a heavy protocol. It's a really strange environment, a really complex environment. What it does all the message transports within this domain service, wireless domain service infrastructure. Everything that is related to WDS is transported over WLCCP. So you have a lot of different message types for different purposes, like the one is for transporting authentication data, like EAP. Other things are for transporting, let's say, simple management tasks up to radio frequency measurement data and all that stuff. And basically we have about two encapsulation modes for this, because there are several packages which are only relevant within the local subnet. So within the local subnet, you just encapsulate all the stuff into an Ethernet packet, send it out. That's okay. If you need to have a further view of the network, you have to be IP-based. So the second encapsulation is UDP-based on port 2887. And what really helped understanding, parts of the protocol, is that there's a Wireshark parser which covers at least some parts of that protocol. So it's a good starting point to dig into the protocol, but it's somehow, at some point, the support for that protocol stops, and then you're on your own. You really have to look at the bytes and bits of the packets itself. What the so the question is, what kind of traffic is it? This is normally this is let's say, for example, if you have authentication data, your authentication server is somewhere located in your data center, then you're not able to contact that server through Ethernet encapsulated packets. So this is typically the kind of data which is IP encapsulated, and stuff like announcement, which is the current WDS master in a network segment. This is typically encapsulated using Ethernet. So it depends a little bit on what the message types are for. What happens, or what is a great thing within that, everything is authenticated. Even in an access point that is providing wireless access to a mobile node is authenticated within the complete infrastructure before it can communicate, before a wireless client can use that access point, which is what we call the infrastructure authentication. This will become a big part in what we're just talking about. And the second thing is we have client authentication, which is just 802.1x on wireless, which is somehow just transported over WLCCP. That's also because there are somehow critical data, sensitive data like encryption keys, really transporting encryption keys over the network. There's of course you have requirements to confidentiality and to authentication, so there's some keying material which is at first, you don't see it, the so-called network session key. The network session key is derived by an EIP method called LEAP. It's a Cisco protocol. And afterwards, they establish a so-called context transfer key, which is for they say higher encryption. We're coming back to this later. So what the big idea behind all this is, if you have imagine an enterprise environment, you have, of course, roaming because you have larger coverage area. And imagine something like a VoIP phone over wireless. You walk from the coverage area of access point A to a coverage area of access point B. If you don't have any mechanism to really do a fast roaming, your wireless connection will drop, your call will drop, and you have somewhere between 5 and 10 seconds until you again re-authenticated to the wireless network. That sucks, really. That sucks. So what they're trying to do is have a fast handoff. You can roam within less than 150 milliseconds from one access point to the other one without your call dropping, for example. For that, they introduced a feature called Cisco centralized key management. On wireless networks, when you encrypt, you have a so-called pairwise master key, and which is the key that is used for encrypting the wireless data. And to make it easy, they just said, okay, we'll modify a little bit on the concept how the key is derived. This is the CCKM, which is client-side feature. And on the back side, within our network, between the APs, we just cache that authentication data, and we make it able to transport the pairwise master keys from access point A, which the mobile node is just leaving, to access point B. So access point B just reuses all the encryption data or all the keying material. That is the big idea, and this is how you can really fasten up that roaming process very heavily. So, this is where I'll just get back to Enno.
I mean, some of you might vaguely remember we already is a mobile mic that we might have. It's another one, so we don't have to switch this every time. I mean, there's not too many switches, but again, some of you might remember we already at some point covered WLCCP in our Shmoocon 2008 talk about layer 2 fuzzing. That is the slide on WLCCP from the time. And at that point, we just fuzzed it and found out that somehow, or we fuzzed some sub-protocols, as WLCCP requires a lot of state. Again, it's a very, very complex protocol. And at the time, we just had a very limited understanding of some types, and the fustos and access points crashed.